So for unequal intervals, for unequal interval you will use Newton divided difference. So consider a Newton's divided difference So we have f of x equals f of x naught plus x minus x naught into f of x naught comma x1 plus x minus x naught into x minus x1 into f of x naught comma x1 comma x2 plus x minus x naught into x minus x1 into x minus x2 into f of x naught comma x1 comma x2 comma x3 plus so on. So this is Newton divided difference. Now we have to differentiate with respect to x. So here x is not there, it is x naught is there, so x naught is constant, so this becomes 0. Now what do you get? F dash of x, this becomes 0, and here x minus x naught, you have to differentiate with x, so you will get 1 minus 0 you will get into, this is the function, so you will get f of x naught comma x1 as it is. So here also x is 1, x naught becomes 0, and x is 1, and here x1 becomes 0. x1 is constant, x naught is constant, and x2 is also constant. So this becomes, now here I'll write the directly formula here, f of x naught comma x1 plus here x minus x naught in plus x minus x1 into f of x naught comma x1 comma x2 plus x minus x naught, here you have to use the product rule. Okay, so we have to use the product rule. Here also we used product rule, and here also you have to use the product rule. So here into x minus x1 plus x minus x1 into x minus x2 plus x minus x3 into x minus x naught into f of x naught x1 x2 x3 plus so on. Now here this is your first derivative formula. Now again if you differentiate with respect to x, what you get? Second derivative f dash of x. Here this is the constant function, so it becomes 0. Here if you differentiate you will get, here also it is 0, 1 you will get, and here also it gets 0, and here x, if you differentiate x you will get 1 plus 1 you will get 2 times of x naught comma x1 comma x2 plus again you have to apply product rule, so you will get 2 times of x minus x naught plus x minus x1 plus x minus x2 into f of x naught comma x1 comma x2 comma x3 plus so on. So this is your Newton derivative difference formulas, first derivative and second derivative. So I'll go for the problems. First one, find f dash of 3 and f double dash of 7 from the following data. So what are the data given? X and y. So here for 2 it is 10 and for 4 it is 96 and for 5 it is 196 and for 6 it is 350 and for 8 it is 868 and for 10 it is 1746. First you have to check x value is equidistant or not. X value difference same ಇದೆ ಇಲ್ವಾ ಅಂತ ಚೆಕ್ ಮಾಡಬೇಕು. Here 4 minus 2 will get 2, 5 minus 4 will get 1. So ಇಲ್ಲಿ 2 ಬಂತು, ಇಲ್ಲಿ 1 ಬಂತು difference. So it is x is not equidistant. So we have to use the Newton divided difference for a table here. So yeah, I'll take like this. So here x value y equals f of x. So here x naught equals 2 and here y f of x naught value is 10. X1 value is 4, f of x1 equals 96 and here x2 equals 5, f of x2 equals 196, x3 equals 6. You get f of x3 value is 350 and here x4 equals 8, f of x4 equals 868 and x5 equals 10, f of x5 equals 1764. Now here del f of x. So these two difference means f of x naught comma x1 equals 96 minus 10 divided by first term minus last term 4 minus 2. So you will get 43 and these two difference f of x1 comma x2, that means 196 minus 96 divided by first time minus last time x2 minus x1, x2 minus x1, 5 minus 2, so we'll get 43 and here these two difference f of x2 comma x3, so 350 minus 196 divided by first minus last term x3, 6 minus 2, 6 minus 4, so you will get 154 and these two difference f of x3 comma x4, so 868 minus 350 divided by x4 minus x3, x4 minus x3 is 8 minus 6, oh sorry, this one is 5. So you will get 259. So what you get, f of x4 comma x5 1764 minus 868 divided by x5 minus x4, so 10 minus 8, so you will get 439. So what do you get? Second difference. So these two difference, f of x naught, x1, x2. So 43 minus sorry, this one is 100, sorry, 5 minus 4, this one, sorry, 5 minus 4, this is 100. So what do you get? 100 minus 43 divided by x2 minus x0. x2 is 5, 5 minus 2, so you will get is 19. And here these two difference, f of x1 comma x2 comma x3. So 154 minus 100 divided by x3 minus x1. x3 minus x1 is 6 minus 4, so we will get 27. And here f of x2 comma x3 comma x4, 259 minus 154 divided by x4 minus x is 2. x4 minus x2 means 8 minus 5, so you will get 35. And last difference, f of x3 comma x4 comma x5. So 439 minus 259 divided by x5 minus x3. x5 minus x3 means 10 minus 6, so you will get 45. And here delta q f of x. So these two differences, f of x naught, x1, x2, x3. So 27 minus 19 divided by x3 minus x0. x3 minus x0 means 6 minus 2, so we will get 2. So these two difference, f of x1, x2, x3, x4 equals 35 minus 27 whole divided by x4 minus x1. So 8 minus 4, so you will get answer is 2 will get. And here last difference, f of x2, x3, x4, x5 equals 45 minus 35 divided by x5 minus x2, 10 minus 5, so you will get 2. So all are same, so no need to find out the next difference, because next difference will get 0. Now you have to write the formula. So what is the first derivative formula? Here first derivative formula, here f dash of x equals you will get f of x naught comma x1 up to, where you have to write up to third degree. You have to write the formula up to third degree. That means x0, x1, x2, x3 plus I get x minus x0 plus x minus x1 into f of x0 comma x1 comma x2 plus x minus x0 into x minus x1 plus x minus x1 into x minus x2 plus x minus x3 into x minus x0 into f of x0, x1, x2, x3. So we know all the values. Here what you have to find out? You have to find out f dash of 3. So put x is equal to 3, and here we know the values for x, x0, x1, x2 and x3 values. Here x0, x1, x2, x3, x4, xy values. And here you know that f of x0 comma x1 value, f of x0 comma x1 x2 value, f of x0 x1 x2 x3 values. So substitute those values. So after some simplification you will get f dash of 3 is equal to 41. Now you have to find out f double dash of x. So here the formula is 2 times of f of x0 comma x1 comma x2 plus 2 times of x minus x0 plus x minus x1 plus x minus x2 into f of x0, x1, x2, x3 plus so on. So what you have to find out? F double dash of, next is f double dash of 7. Put x is equal to 7. So 2 times of, what do you get here? Value it is 19 plus 2 times of, here x value is 7. 7 minus 2. 7 minus 2 means 5. And here 7 minus 4 is 3. 7 minus 5 is 2 into what is f of x0, x1, x2, x3? It is value is 2. So if you simplify, you will get 78. Maximum and minimum. So the necessary condition for y equals f of x, the necessary condition for y equals f of x to be maximum or minimum is f dash of x equals 0. If f of x is, this implies that here f of x is maximum if f double dash of x is less than 0, and f of x is minimum if f double dash of x is greater than 0. So when you get f double dash of equal to 0, neither maximum nor minimum you will get. So remember that one. F double dash of x equal to 0 means neither maximum nor minimum. So here problem, first one I'll do. Find the maximum and minimum values of the function y equals f of x from the following table. So here x values and here y values. Here for 1 it is 9, and for 3 it is 11, and for 5 it is 13, and for 7 it is 63, and for 9 it is 209. Solution. So here what is the working procedure for this one means, here you have to find out the maximum value and minimum value. So first you will write the here the given y is equal to f of x. So first you have to consider here f dash of x here. F dash of x formula, first derivative formula. That means you have to use the forward table. So you will use forward table means then you have to use the Newton's forward formula f dash of x here, first derivative formula. So after that you have to find out the here x values you will get. After that you have to find out f double dash of x here. So second derivative, you have to use the second derivative formula. So after that whatever the x values you will get, you have to substitute here. You will get some values, maximum and minimum, Here f dash of x is less than 0 means it will get maximum. F double dash of x is greater than 0 means you will get minimum points, not value. So remember that one. So only you will consider, you will get here maximum point or minimum points here. So after that you have to find out the maximum and minimum value. So you will use forward formula to find the maximum and minimum value. Remember that one. So first you have to construct the forward table. So x here and y values. So for 1 it is 9, for 3 it is 11, for 5 it is 13, for 7 it is 63, for 9 it is 209. So here delta y, so these two difference means 11 minus 9 you will get 2, and here 13 minus 11 you will get 2, and here 63 minus 13 you will get 50, and 209 minus 63 you will get 146. And here delta square y, so these two difference you will get 0, and 50 minus 2 will get 48, and here this to 146 minus 50 you will get 96, and here delta cube y, so you will get 48 minus 0 you will get 48, and here this to 0, 96 minus 48 you will get 48, and for the difference you will get 0. So this is our delta y and this is your delta square y, and here delta cube y and delta to the power of 4y value. Now next what here you have to find out, you have to use first derivative formula. So here f dash of x equals 1 by h into delta y naught plus 2r minus 1, 2r minus 1 into delta square y naught divided by 2 plus 3r square minus 6r plus 2 into delta cube y naught divided by 6, so on. Now here where r equals x minus x naught divided by h, so r equals what you get, keep x as it is, we don't know, and x naught value it is 1 divided by difference, h difference, 3 minus 2 2, 5 minus 3 2, 7 minus 5 leads 2, so difference is 2. Now here we know that f dash of x equals 0, so here from maximum minimum is f dash of x is equal to 0, I have to take that one first, so I am considering f dash of x is equal to 0, so substitute here 0 equals, here I'll go to this one to right hand side, 0 into anything it becomes 0 only, and here delta y naught value it is 2 plus 2r minus 1 into delta square y naught value is 0, so this whole term becomes 0, so what happened here, 0 plus 3r square minus 6r plus 2 whole into delta cube y naught value is here delta y naught, delta square y naught, delta cube y naught, delta to the power of 4 y naught values, it is 48 divided by 6. So 0 equals 2 plus here 3r square minus 6r plus 2 into here 6 ones are 6 8s are. So what you get, 0 is equal to 24 r square minus 48 r plus 16, and here plus 2 is there. So 0 equals what you get, 24 r square minus 48 r plus 18. Now I will divide with 6 here. So what you get, 4 r square minus here 4 r square, you will get 8 r plus 3 equals 0. Now if you factorize this one, what you get, 2r minus 1 into 2r minus 3 equals 0. But what is r? R is x minus 1 divided by 2. So substitute that one. So what you get, x minus 1 divided by 2 minus 1 into what you get, 2 into x minus 1 divided by 2 minus 3 equals 0. 2 will get cancelled, and here also 2 will get cancelled, so x minus 2 will get here, and here x minus 4 will get equal 0, so x is equal to 2 and x equals 4. So you got x values. Now you have to find out f double dash. So f double dash of x equals, what is the formula, 1 by h square into what you get delta square y naught plus r minus 1 into delta cube y naught. So f double dash of x equals 1 by h means 2, it becomes 4, 2 square means it is 4, and delta square y naught value is 0 plus delta cube y naught is 48 into r minus 1. But here where r equals x minus x naught divided by 2, so this becomes x minus 1 divided by 2. R value is what do you get? X minus 1 divided by 2. So substitute that one. So this one 4 ones are 4, 12s are, so 12 into r minus 1. So substitute r here. So 12 into what do you get? X minus 1 divided by 2 minus 1. So take it LCM. So 12 into x minus 1 minus 2 divided by 2. 2 ones are 2 6 are. So this becomes 6 into x minus 3. So f double dash of x. Now when x equals here, what do you get? X equals 2 value. Substitute that one. X equals 2. So what do you get now? We have f double dash of 2 equals what do you get? 2 minus 1. So you will get minus 6. It is less than 0. When x equals 4, substitute 4 here. We have f double dash of 4 equals, if you put 4 for here, 4 minus 3 you will get 1. 1 to 6, it is greater than 0. So hence f of x is maximum when x equals 2, and f of x is minimum when x is equal to 4. So you got here maximum point and minimum point, that is 2 and 4. Now we have to find out the maximum and minimum values. So we have to find out maximum and minimum values means you have to use the Newton's forward formula. So to find the maximum and minimum values of f of x, we consider Newton's forward interpolation formula. Now consider here what you get, f of x equals what you get, y naught plus r into delta y naught plus r into r minus 1 divided by 2 into delta square y naught plus r into r minus 1 into r minus 2 divided by 3 factorial into delta cube y naught plus so on, where r equals x minus x naught divided by h. So x minus, keep x as it is, minus what is x naught here, sorry, okay, x minus x1 divided by 2. So substitute that one. So f of x equals, what do you get? Y naught value. So y naught value is 9 plus here x minus 1 divided by 2. R value is x minus 1 divided by 2 into what is delta y naught value? Delta y naught value is 0. It is 2. Delta y naught value is 2 plus here x minus 1 divided by 2 into x minus 1 divided by 2 minus 1 whole divided by 2 into delta square y naught value is 0 plus here x minus 1 into x minus 1 divided by 2 x minus 1 divided by 2 minus 1. So x minus 1 divided by 2 minus 2 whole divided by 3 factorial means it is 6 into 48. So this whole term becomes 0. So f of x equals, what do you get? 9 plus x minus 1 divided by 2 will get cancelled. So you will get x minus 1, and here 6 ones are 6 8s are. So plus x minus 1 divided by 2 and x minus 1 divided by 2 minus 1 and x minus 1 divided by 2 minus 2 into 8. Now find out what x is equal to 2. X is equal to, if you put x is equal to 2, if you substitute, you will get the value is 13. And if you put x is equal to 4 for this equation, the values will get 9. So therefore the required maximum value of f of x is 13 and the minimum value is 9. So this is the solution.